Yes, sir.
Good evening, Ramchand. Today I would like to explain our data science training module 3, that is statistics. What is meant by statistics? Study of numbers, study of numerical operations like addition, subtraction, multiplication, division, average, standard deviation, and variance. So many operations, mean, mode, so many operations we are performing under statistics. So this is the syllabus of statistics. In real life, we are using the statistics in many purposes, like if you are checking your own examples, or if you want to perform any weather forecasting temperature of data, there also we are using prediction algorithms like linear regression, nonlinear regression, logistic regression. So this is the syllabus of statistics: types of data, fundamentals of statistics, what are the statistical operations like mean, mode, and standard deviation, probability, hypothesis testing, regression analysis, correlation, classification techniques, and confidence intervals, ANOVA, analysis of variance. So this is the syllabus of statistics, and the extension of core statistics, we have a descriptive statistics, probability distributions, statistical inference, regression analysis, statistical modeling, Bayesian statistics, sampling methods, time series analysis, multivariate analysis, experimental design. So we will see the various concepts of statistics. Statistics is usually we are using in order to perform various operations with developing and studying methods for collecting the data and analyzing the data and interpreting the data and presenting empirical data. Empirical means mathematical data. Finally, we are displaying mathematical representation of the data. That is called statistics. Statistics can be used to derive meaningful insights from data by performing mathematical computations on it. If you take analysis, what we are doing, whether you are doing quantitative analysis and qualitative analysis. Quantitative means size of the data. What is the size of the data are you handling? That is called quantitative analysis. Then qualitative analysis means what type of quality of data we are performing. Okay, so there are various techniques and tools and techniques are available in statistics. So statistics is a branch of mathematics that deals with the collection of data and analysis of the data, interpretation of the data, and the presentation of the data. So that's why in data science, statistics playing a vital role and a critical component, because it provides a framework for understanding and making decisions based on the data. Statistical techniques such as regression analysis, hypothesis testing, and machine learning algorithms are widely used in data science to identify patterns and relationships in data, make predictions and classifications, and inform decision making. Statistics is an essential tool in the field of data science, providing the methodology for analyzing data and extracting meaningful, interested patterns, insights that can inform business decisions, improving products and services, and drive innovations. So that's why statistical methods like descriptive methods, inferential methods. Descriptive methods, we are describing that data set or data like univariate descriptive methods. Under that we have shape, center, spread, relative position. Bivariate descriptive analysis like correlation, regression. Multivariate means multiple variables, multiple regression. Inferential methods like central limit theorem, binomial theorem, hypothesis and significance testing, normal distribution applied to means like a t-test and ANOVA, analysis of variance. Then data is a raw material Data may be audio, video, text, graphics, anything can be in this world is a data. So data can be classified into two types like qualitative data, quantitative data. Qualitative data, again, we are classifying like a categorical data, like attribute. Data that refers only to name classifications like marital status, like single, married, widow, like political party, eye color. Okay, these are the categorical data. That is called the qualitative data. Okay,
Yes,
so
sir.
then quantitative data is nothing but we are classifying into two types like discrete quantitative data, continuous quantitative data. Discrete means there is no continuation. So there are counted items like number of children, defects per hour in a software. Those are the examples of discrete data.
Sir, can we
Continuous,
say static as discrete?
yeah, 100%.
Okay,
Yeah.
sir.
So continuous means our age is continuously growing,
Yes, sir.
and our weight also sometimes continuously growing, voltage also continuously growing. Measured characteristics is nothing but continuous quantitative data. Then there are various graphs we are generating like operations, you can call it as central tendency. So how do you can calculate central tendency by using mean, median, mode, outliers? Then how do you measure of spread by using a range, standard deviation, variance, quartiles, etc. Then percentiles, how do you can calculate like position of data, percentile rank, percentile range. We are using percentiles. Then probability distribution is nothing but we have uniform distribution, normal distribution, that is also called as a Gaussian distribution, binomial distribution, etc. Then dimensionality reduction, redundant particles, redundant data we are removing on the phase, similar data. Dimensionality reduction, we are using pruning technique and principal component analysis. Sampling is a statistical operation. We are performing operations like software requirement specification SRS, reservoir, undersampling, and oversampling. Then Bayesian statistics. Bayesian is a scientist has been proposed measuring belief or confidence concept by using P of A by B equal to P of B by A multiplied by P of A by P of B. That is called Bayesian statistics. Then covariance and correlation. Covariance in the matrices, we are calculating covariance matrix like positive correlation, negative correlation, how data is related. Whether the data is related, then we are performing correlation techniques. So these are the basic probability and statistical operations. What are the examples of statistics? See, average is an example for statistical operation. So the average height of a group of people, then the percentage of voters who support a particular political candidate, the median income of a particular city, the standard deviation of a set of test scores, the correlation coefficient between two variables such as age and income, the probability of a particular event occurring such as rolling a 6 on a dice, the frequency distribution of a set of data as the number of times each letter appears in a given text, the confidence interval for a particular measurement such as the margin of error in a political party, okay, political poll, the coefficient of determination in a regression analysis which measures how well a line of best fit predicts data points, And finally, we are testing the test or ANOVA analysis of variance, which are statistical tests used to determine whether there are significant differences between two or more groups or samples. So these all are examples of statistics. Then a statistics formula mean x bar equal to x sigma xi by n, variance equal to sigma xi minus x bar whole square by n, median equal to n plus 1 term by 2 term when n is even. nth nth term of n by 2 term plus n by 2 plus 1 term divided by 2 where n is even. Mode, how do we can calculate the value in the data set that occurs most frequently. These are the basic formulas of statistics, and these are the statistics for data science we are using. Like why we are using statistics, it is used to process complex problems in the real world so that the data scientist and analyst can look for meaningful trends and generating interested patterns, interested analytics and changes in data. That is called statistics. Statistics can be used to derive meaningful insights from data by performing mathematical computations on it. So these are the basic formulas of statistics, like population measures and sampling measures, linear regression measures, probability formulas, one sample Z statistic, one sample T statistic, two sample T statistics, sample proportion, two sample proportions, size square statistic, central limit theorem. These are the basic statistical formulas we are using.
Sir, one question.
Yeah.
Sir, for interview point of view, if these formulas are, let's say if I study all these formulas, can I expect these formulas as questions in the interviews?
They won't ask the formulas. They will ask where to use linear regression, when to use a sampling method,
So
like that.
basically the
Regression
applications they will ask.
application point of view, they will touch the questions.
Okay.
But if you know these formulas, we are using in validation metrics, but nobody can remember these many formulas. Okay.
Yes, sir.
At the point of requirement, we are using that formula for justification of our model, whether correctly classifying the data, correctly performing the data. Those things we are calculating by seeing these formulas.
Okay, so maybe can I say like the linear regressions, where it is used, how it is used, why it is used, something like that I can prepare.
Mm-hmm. Yes, 100% we are expecting.
Okay.
And in detail, we will see all these formulas in the coming classes.
Okay,
Okay.
sir. Okay, sir.
Then what are the major concepts of statistics? So we have various concepts like descriptive statistics, what it describing. So it descriptive means we are summarizing and describing data using measures such as mean, median, mode, standard deviation and range. So finally we are displaying summarizing data with the help of these operations, statistical operations like mean, median, mode, standard deviation, range. That type of statistics is called descriptive statistics. What is meant by inferential statistics? It involves drawing conclusions like decisions, final points, final thought, or making predictions about a population based on a sample of data. That is called inferential statistics. Probability, this is the study of random events and their likelihood of occurrence, is called probability. Hypothesis testing, this involves testing a hypothesis or a claim about a population using a sample of data, is called hypothesis testing. Sampling is nothing but this involves selecting a representative subset of a population to collect data from various samples. Then what is meant by correlation? So correlation means this measures the strength and the direction of the relationship between two variables. Like one person is similar to another person, when we can say if the two persons are similar to each other, like twins, sometimes we are confusing because their face, their body structure, everything is similar. So in that case, we used to call it as a correlation. Okay,
Yes, sir.
relationship between two variables. Then regression means this involves modeling the relationship between one or more independent variables and a dependent variable. That is called regression. Confidence intervals is nothing but these are range of values that are likely to contain the true population parameter. Statistical significance. This is a measure of the likelihood that a result is not due to chance. So that is a statistical significance. Experimental design. Sometimes we are performing a population as experiment. This involves designing and conducting experiments to test a hypothesis and draw conclusions about populations. Then there are 8 basic statistics concepts where if you want to become a data scientist, you need to have these 4 important concepts, like 8 important concepts. Understand the type of analytics, probability, central tendency, variability, relationship between variables, probability distribution, hypothesis testing, and statistical significance and regression. So understand the type of analytics, what type of analytics you are performing, like whether you are performing descriptive, diagnostic, predictive, and prescriptive. Descriptive, just now we have explained. So tell us what happened in the past and helps a business understand how it is performing by providing context to help stakeholders interpret information. That is called descriptive analytics. Diagnostic analytics means takes descriptive data a step further and helps you understand why something happened in the past. Then predictive analytics is nothing but predicts what is most likely to happen in the future and provides companies with actionable insights based on the information. Then prescriptive analytics provides recommendations regarding actions that will take advantage of the predictions and guide the possible actions towards a solution. Then what is meant by probability? So probability is the measure of the likelihood that an event will occur in a random experiment. If you are throwing a coin, who knows, head will be the winning or tail will be the winning. There is a 50-50 chances, So that is called a random experiment. Probability is the measure of the likelihood. We are expecting that event will occur in a random experiment. Like a complement, we are using P of A. What is the complement of P of A? P of A.
Yeah.
P of A dash. P of A plus P of A dash equal to 1. Then what is meant by intersection? Common variable between A and B. Okay, that is P of A intersection B equal to P of A multiplied by P of B. What is meant by union? P of A union B equal to P of A plus P of B minus P of A intersection B. So we are combining A elements with the B elements, which are different. Okay.
Yes, sir.
So the diagram indicates the first one indicates intersection and second one indicates that union. Then conditional probability. P of A by B is a measure of the probability of one event occurring with some relationship to one or more other events, like P of A by B equal to P of A intersection B divided by P of B, when P of B greater than 0. Independent events, two events are independent if the occurrence of one does not affect the probability of occurrence of the other. P of A by B equal to P of A multiplied B, P of B, where P of A not equal to 0 and P of B not equal to 0. Then P of A by B equal to P of A, comma, P of B by A equal to P of B. Then what is meant by mutually exclusive events? Two events are mutually exclusive if they cannot both occur at the same time. Like P of A intersection B equal to 0 and P of A union B equal to P of A plus P of B. Bayes theorem, why we are using? It describes the probability of an event based on prior knowledge of conditions that might be related to the event. If you see the example of Bayes theorem, P of A by B, that is called posterior probability, equal to P of A intersection B by P of B. That is equal to P of A multiplied by P of B by A divided by P of B. So P of A is nothing but the prior probability, where A and B are events and P of B not equal to 0. Then what is meant by central tendency? What are the operations we are performing? Central tendency consists of five concepts like mean, median, mode, skewness, kurtosis. Mean is nothing but the average of the data set. Everybody knows. Median is nothing but the middle value of an ordered data set. That is correct. Mode is nothing but the most frequent value in the data set. If the data have multiple values that occurred the most frequently, we have a multimodal distribution. Then what is meant by skewness? Skewness is a measure of symmetry, like similarity between A and B. Then kurtosis is nothing but a measure of whether the data are heavy-tailed or light-tailed relative to a normal distribution. If you see skewness, how three sinusoidal graphs are similar to each other. Kurtosis, how these three conditions satisfy in the graph. Then variability. Variable is nothing but varying value at runtime duration. That is called variability, changing at any time. Range, what is meant by range? The difference between the highest and lowest value in the data set, like percentiles, quartiles, and interquartile range IQR. We need to have percentiles, quantiles, interpretile range IQR. Like percentile, a measure that indicates the value below which a given percentage of observations in a group of observation falls. Quartiles is nothing but values that divided in the number of data points into four more or less equal parts or quarters. IQR is nothing but interquartile range, a measure of statistical dispersion and variability based on dividing a data set into quartiles, like IQR equal to Q3 minus Q1. If you divide it, if you subtract, you are getting Q2. Like if you see the example, outliers means abnormal behavior, abnormal points. Then we are getting minimum to maximum value, IQR range. Then what is meant by variance? The variance is an average square difference of the values from the mean to measure how spread out a set of data is relative to mean. What is meant by standard deviation? The standard difference between each data point and the mean and the square root of variance, like population. We are using variance sigma square equal to sigma of xi minus mu whole square by capital N. Standard deviation, sigma equal to square root of sigma xi minus mu whole square by n. Sample, what is the formula we are using? S square equal to sigma of x1 minus x bar whole square by n minus 1, where standard deviation S equal to square root of sigma xi minus x bar whole square by n minus 1. This is population and sample variance and standard deviation. What is meant by standard error? That is called sometimes whenever you are running a program, we are reducing the error. That error is called standard error. If you reduce the error, you are getting very good accuracy. An estimate of the standard deviation of the sampling distribution, like population standard error. So sigma x bar equal to sigma by square root of n. Estimate sigma x bar is more or less similarity index. Negation is called similarity index s by square root of n. For sample, we are using s x bar equal to s by square root of n. This is the population and the sample standard errors. Then the relationship between variables. So there are three relations we are using variables. Variables are varying value at runtime duration. So variables are different types like static variables, dynamic variables, okay, and register variables, local variables, global variables, etc. So here three important formulas like causality. Causality is nothing but relationship between two events where one event is affected by the other. Covariance, a quantitative measure of the joint variable between two or more variables. That is called covariance. Correlation measures the relationship between two variables and ranges from -1 to 1. The normalized version of covariance is called a correlation. So we are using formulas like covariance and correlation, different formulas, positive relationship, negative relationship, no relationship. Covariance, how do we are calculating? 1 by n equal to covariance of x comma y. 1 by n equal to 1 by n sigma I to n xi minus x bar y1 minus y bar. Then we are using correlation formula, correlation of x comma y, covariance of x comma y by square root of variance of x multiplied by variance of y. The way we are using relationship between variables. Then probability distribution, we have three important distributions like probability and mass distribution, probability density function distribution, and cumulative density function. That is called CDF. If you see the graph, we have x-axis discrete and continuous. Y-axis we have cumulative and non-cumulative. So what is meant by probability mass function? PMF.
Non-cumulative and discrete.
Yeah. Probability mass function. A function that gives the probability that a discrete random variable is exactly equal to some value. What about PDF? Portability density functions.
A
But
non-cumulative and continuous.
but a few people are confusing this probability density function like PDF, portable document file format. That is
Okay.
different,
Okay.
and this is different. Probability density function. So what it means, it is a function for continuous data where the value at any given sample can be interpreted as providing a relative likelihood that the value of the random variable would equal that sample. Then a cumulative density function like CDF, a function that gives the probability that a random variable is less than or equal to a certain value. So this is a comparison between PMF, portability mass function, PDF, portability density function, and CDF, cumulative density function. If you see y-axis, we have cumulative and non-cumulative. In x-axis, we have PMF and PDF. Then continuous probability distribution, we have two more functions like uniform distribution, normal distribution. Uniform distribution, also called as a rectangular distribution, is a probability distribution where all outcomes are equally likely. Then we are going for normal and Gaussian distribution. The curve of the distribution is bell-shaped and symmetrical and is related to the central limit theorem. That the sampling distribution of the sample means approaches a normal distribution as the sample size gets larger. If you see the uniform distribution diagram, 0 to x, a and b are the values. We are performing y-axis 0 to f of x, that is 1 by p minus a. Then we are going for a normal distribution. See, fantastic normal distribution graphs we have generated. Then experimental distribution, that is nothing but a probability distribution of the time between the events in a Poisson point process. Chi-square distribution is nothing but the distribution of the sum of squared standard normal deviates, like exponential distribution. X-axis we have a 0 to 5, probability we have a 0.5 to 1.5. That is probability density. Chi-square distribution, it is the example. Then discrete probability distribution, we have three types like Bernoulli distribution, binomial distribution, Poisson distribution. Okay. Bernoulli distribution says that the distribution of a random variable which takes a single trial and only two possible outcomes, namely I success with the probability P and 0 failure with probability 1 minus P. Then we are going for binomial distribution is quite interesting. We are using all the applications. Maximum. The distribution of the number of success in a series is success in a sequence of n independent experiments and each with only two possible outcomes, namely I success with probability P and O failure with probability 1 multiplied by 1 minus P. Then the Poisson distribution is nothing but the distribution that expresses the probability of a given number of events k occurring in a fixed interval of time if these events occur within a known constant ranging rate. So this is about Poisson distribution. If you see the examples like Bernoulli distribution, how it look like, and the binomial distribution, how it look like, and the Poisson distribution. And the three are very popular in a Poisson distribution. Hypothesis, last but one topic, hypothesis testing and statistical significance. This is theory parts we are explaining. After that, we'll start practicals. Hypothesis testing and statistical significance. What does that mean? There are null hypothesis and alternative hypothesis, and B contrary, like these are the a general element that there is no relationship between two measured phenomena or no association among purposes. Then alternative hypothesis, by contrary to the null hypothesis, in statistical hypothesis testing, a type 1 error in the rejection of a rule, null hypothesis, while a type 2 errors is the non-rejection of a false null hypothesis. Then interpretation is nothing but it is a one more operation. Here we are solving three types of concepts like p-value, critical value, significance level, and rejection ratio. P-value is nothing but the probability of the test statistic being at least as extreme as one observed, giving that the null hypothesis is true. So if when p value greater than alpha, we fail to reject the null hypothesis. While p value less than or equal to alpha, we reject the null hypothesis, and we can conclude that we have a significant result. And the critical value, a point on the scale of the test statistic beyond which we reject the null hypothesis and is derived from the level of significance or of the test. Significance level and rejection region. The rejection region is actually independent on the significance level. The significance level is denoted by alpha and is the probability rejecting the null hypothesis. Now we will see Z test. We are using a statistical test for which the distribution of the test statistic under the null hypothesis can be approximated by normal distribution, and test the mean of a distribution. If you see Z test, which are the distribution of the test static under the null hypothesis can be approximated by a normal distribution, and test the mean of a distribution in which we are already know the population variance. Many statistical tests can be conveniently performed as approximate Z test. If the sample size is large, the population variance is known. This is one sample Z test, that is two sample proportional to another test. Then t-test, why we are using? It is a statistical test if the population variance is unknown and the sample size is not known. Large number of greater than equal to 10. Then period example, measuring data which collect and twice from the same group, person, item, or enhancing. So we are using in this paid sample like independent sample. It implies that two samples must have come from two completely different populations. If you see a one sample test, we have different formula. Paid sample and a two sample test, like equal, same size, not revolution. Okay, then we are moving to ANOVA, analysis of variance. It is ANOVA is the way to find out if experimental results are significant. One-way ANOVA, two-way ANOVA. Two-way ANOVA is also called as multi-level ANOVA. Like one-way ANOVA compares two means from two independent groups using only one independent variable. Then the two-way ANOVA is nothing but it is extension of one-way ANOVA using two independent variables to calculate the mean effect and interpret codes. Then two-way ANOVA we are using is the extension of one-way ANOVA using two independent variables to calculate mean effect and interaction effect. If you see the examples, source treatment error total, sum of six squares, degree of freedom, tan square F. Okay, then the last but one concept, chi-square test. Chi-square test checks whether or not a model follows approximately normality when we have a discrete set of data points. Like a goodness of fit test determines if a sample matches the population fit, one categorical variable to distribution. Oddness of the fit test is nothing but determines if a sample matches the population fit, one categorical variable to a distribution. If you see the chi-square test for independence, it compares two sets of data to see if there is a relationship, like observed value, O stands for, E stands for expected value. That is x square C. Then we are performing this operation, chi-square test formula. So these are the, see, one second. So counting permutations and combination, these are the special concepts, permutations and combination. The number of ways to arrange n unique items in R slabs order matrix. P of n comma r equal to n factorial by n minus r factorial. This formula you know very well. Ramchan,
Yes, sir.
permutation. Then combinations, the number of ways to choose r items from n items, like order doesn't matter. That's why C of n comma r and purpose of r multiplied with n minus r. Probability axioms, like probability is always between 0 and 1. P of S, the population of the sample space is S is 1. P of A union B equal to P of A plus P of B minus P of A intersection B. That is called union of events A and B. Sample space and events. Sample space, the set of all possible outcomes of an experiment. Events is nothing but a subset of sample space. Then types of events, we have two types of events, like independent events, mutually exclusive events. Event A and B are independent if P intersection B equal to P of A multiplied by P of B. Mutually exclusive events, like events that cannot happen simultaneously, like P of A intersection B equal to 0. Marginal, conditional, and joint probability. Marginal probability says that P of A or P of B, the individual probabilities. Conditional probabilities, like P of A by B, that is a Bayesian theorem, like P of A by B equal to P of A intersection B divided by P of B. Joint probability, P of A intersection B, comma, the probability of both events happening. Bayes theorem, P of A by B equal to P of B by A multiplied by P of A divided by P of B. These are the expectation and variance. What is meant by conditional expectation? The expected value of random variable given some condition. Conditional variance, the variance of a random variable given some condition. Mean, the average, median, the middle value, mode, most frequently occurring value, standard deviation, the square root of the variance. Correlation and covariance. Correlation is nothing but measures the strength and the direction of the relationship between two variables. Covariance measures how two variables change together. Then random variables and distribution. So all this one we have explained already. These are the short forms of each one. Okay. So the ninth one is a regression. From here onwards, you are getting programs. Ramchan.
Okay, sir.
So how much time is there so that at least we can execute one program? No?
15 minutes, 1 5.
Okay, we will, can you stay 15 minutes? No problem?
Yes, sir, yes.
Okay. So regression means it is a statistical method used in finance, investigating or investing or other disciplines that attempts to determine the strength and the character of the relationship between one independent variable, usually denoted by Y, and a series of other variables known as independent variables. These are linear regression, nonlinear regression, and logistic regression, linear relationship, multivariate normality. So these are the types of regression, like linear regression, logistic regression, polynomial regression, more variables, stepwise regression, ridge regression, lasso regression, elastic net regression, etc. So these are the steps we are following in statistics, like start, data collection, data description, and so on steps. Finally, we are getting dashboard for monitoring and logging reports. So these are the so many steps we are performing, like see, the third step, data description, a story of what data is all about and the features present in the data. Entire statistics is there in this flowchart. Then performing both statistical and graphical data analysis, then data transformation and a derivation of new attributes if necessary, selection of a machine learning algorithm based on the patterns observed in EDA, exploratory descriptive analysis, then data standardization, normalization, correlation of train and test data sets using optimum parameters, model training using the machine learning algorithms tested above, calculation of model accuracy, both training and test accuracies, hyperparameter tuning to achieve a better accuracy, saving the created model file, deployment strategies for the model, live stream or batch or mini batch, production deployment and testing, finalizing the retraining approach, logging and monitoring, maintaining the audit tables, finally dashboard for monitoring and logging reports and stop. So types of data, we have seen classification of data into qualitative, categorical, and quantitative, numerical. Fundamentals of statistics, core principles such as data collection, sampling, and summarizing data. Mean, mode, and standard deviation, we have seen measures of central tendency, mean, mode, and variability, standard deviation. What is the probability? The study of randomness and the likelihood of events occurring. Hypothesis testing, statistical method to test assumptions or claims about population parameters. If you see the regression analysis, it is a technique that model and analyze relationship between variables. Correlation means measure of the strength and the direction of the relationship between two variables. Classification means grouping data into predefined categories or classes. Confidence intervals, a range of values used to estimate the true value of a population parameter. ANOVA is nothing but analysis of variance. It is a method to compare means across multiple groups to determine statistical significance. Then the first method is a linear regression. So this is a linear regression is we are modeling the relationship between dependent variable and one independent variable. An independent variable is a variable that is controlled in a scientific experiment to test the effects on the dependent variable. A dependent variable is a variable being measured in a scientific experiment. A linear regression line has an equation of the form y is equal to a plus bx, where x is the explanatory variable and y is the dependent variable. The slope of the line is p and a is the intercept, the value of y when x equal to 0. Now this is the formula we are using, like y is equal to mx plus c, where y is the dependent variable, x is the independent variable, and m is the slope, and c is the intercept value. See, 3 times it printed actually. And now we are writing a program. See, this is the linear regression. We are getting, see, what are the variables in the linear regression? Dependent variable, that is yi, that is called response variable. And b naught is y-intercept plus p1 slope quotient, xi independent variable, that is predictor, plus sigma I error term. If you see, one small example we are solving right now, Ramchan.
Yes, sir.
There is a problem like a student studies 2 hours, he is getting 60 marks. Okay. So the aim of the program is we are developing a model, the relationship between the number of hours studied and the scores on a test. We collect data on the 10 students and record the number of hours studied and their corresponding test scores. 2 hours if the student studies, and dependent variable is y, 60 marks. X is an independent variable. 3 hours 70, like 11 hours 150. Can you write program for this one? Now we are writing.
Okay.
So using the above data, we are calculating the slope and intercept values using the following formula, like this. B is equal to n multiplied by sigma of x multiplied by y minus sigma x multiplied by sigma y divided by n multiplied by sigma x square minus sigma x square. A is equal to sigma y minus b multiplication sigma x by n, where n is the number of data points after calculating the values of the slope and intercept, we can use them to predict the test score for a given number of hours studied. For example, how do we can calculate the student studies for 7 hours? We can predict their test score using the following formula, like y is equal to mx plus c. So here a plus bx. So if he studies minus 10 plus 7 hours, if he studies minus 10 plus 15x, how you are applying here y is equal to minus 10 plus 15 of 7, x place we are replacing 7 hours, then we are getting 15 sevens are 105, we are reducing minus 10 and we are getting 95. So therefore, we can predict that a student who studies for 7 hours will score 95 on the test. We need to write a program. We need to get 95 for us if a student studies 7 hours. So this is the program.
Sir, 1 minute. In the previous slide, the minus 10 value, was that a constant value we take or?
Yeah, constant value we are taking.
Okay.
So now see here, you can understand very easily. So write a Python program to perform linear regression in Python code. Import NumPy as NP, import matplotlib.pyplot as PLT. We are taking input data and y data, and we are calculating slope and intercept values. Then we are calculating, make a prediction for a given number of hours studied. Then a test score equal to a plus b multiplied by hours studied. That means we are printing a predicted test score for hours studied test score. We are plotting the data and regression line. In this one, logic part is n, what is n, what is b, what is a. You need to calculate. Okay. So we are printing the if 7 hours studied, he has to get 95%. Suppose 7 hours he is getting 110 marks. So this program you need to execute. How much time is there?
Only 5 minutes.
Okay. So tomorrow can you execute this program?
Yes, sir. Yes, sir. Maybe, sir, can you just give me some input? Insights. Let's say n is equal to length of x, isn't it, sir? So
yes.
we have from 2 to 11.
How many numbers are there?
So 10 numbers.
Length.
10 numbers.
Yes. Yeah, that 10 we are taking.
Okay. And this B, that's a formula, isn't it, sir? The B.
Yes.
Okay.
B is a formula.
A is also a formula.
Yeah. A is a formula.
Okay. So make a
Then we are going to perform a Python program.
Okay. Okay, sir.
Tomorrow we'll do this program.
Okay, sir. Okay, sir. Sure, sir. Thank you.
Tomorrow we'll execute. Okay.
Thank you, sir.
We'll stop here. Yeah.
I will save the recording. I'll send you. Maybe after some time I will send you, sir. Now I have to go to the department.
No problem. And I will share this PPT also. You can go through it.
Yeah,
okay.
sure, sir.